Okay, so in our previous lessons, we've looked at two ways to solve a system of equations. We've looked at graphing. Remember, with graphing, we use a visual to see where the intersection point is, where the common solution is. Remember, graphing is just the method. You have to look. Don't just graph it and think that you're done. Remember, you have to actually look to find where the intersection is and record that coordinate. But the problem with graphing was, for one, it can be time consuming if you don't have a calculator to graph it, and for two, it doesn't always intersect at integers, so you'll be guessing or estimating what the solution is if it's going to be decimals. Then the next way we learned about was substitution. That's what was the previous lesson is what we did, and in that one we substituted one value in for another. Now the disadvantage to that is you had to have one of the variables solved, or you had to have it solved for one of the variables, meaning we had to get either y or x or what other variables we're using, one of them by itself, and then substitute that chunk into the other equation. So there's a third way, and that's called elimination. So if you look at the example that I have here, if I had to graph this, this would not be a fun one to graph. Just from the looks of it, it looks like it would take some time. And for two, if I wanted to use substitution, I'd have to get one of these variables by itself, and to do that, since there's so many numbers in here, I'd be opening myself up to making maybe some algebra mistakes. So there's this other way, like we said, called elimination. And it's exactly what it sounds. We're going to try to eliminate one of the variables. To do that, I'm going to multiply one of the equations by a number. So I'm trying to get two of the variables to match up with opposite signs, meaning, looking at this first equation, if I were to multiply this first equation by a -2, -2 times -8x would make that a positive 16x. Then I'd have a -7y, so that's going to be -14y, and that would be equal to -2 times -29. Now that would be a positive 58. So now I'm done with that first equation, but notice with this new equation that I just came up with, and the other equation that I didn't do anything with, the -16 and the 16x, if I add these two equations together, the x's will be gone, because -16x plus 16x is 0, so it's 0x or no x's, and 2y plus -14y, well, that's going to be -12y, and -22 plus 58 is going to be a positive 36. So now I just divide both sides by -12, and I get that my y value is -3. So remember, I'm not done. Remember, I have to figure out what x is. It doesn't matter which equation I use. I can put -3 into the first one or -3 in the second one. Well, let's just say we do it in that first one. So it's -8x plus 7 times -3 equals -29. Well, 7 times -3 is -21. So if I add 21 to both sides, I get -8. So you can see now that if I divide both sides by -8, x equals, well, -8 divided by -8 is a positive 1. So I get that x equals 1 and y equals -3. So essentially that's elimination, and that's what we're going to focus more on today. But these are the three ways that we're going to look at solving systems of equations. Each of these have their advantages and disadvantages. The disadvantage to the elimination would be that it has to be set up as a linear combination equation, or it has to be set up in standard form. Now the book describes this method as instead of using elimination, they use the term linear combinations. So let's look at our notes. Okay, so now let's look at some of these other examples. So here it says, solve the system x plus 2y equals 11 and 3x minus 9y equals 23 by the linear combination method. So again, they refer to it as a linear combination method. I don't like referring to it in that way, because it's really not the method we're putting it, linear combinations. Linear combination is the form that we have to have the equations in. But it's not the method getting rid of one of the variables. We're eliminating one of the variables, which makes more sense to use that. So let's look at what we could do here. So I look at all my variables, so I have an x and a 3x and a 2y and a 9y. If I want to get rid of the y's, there's no integer, and we always want to use integers, not fractions or decimals. There's no integer that I can multiply 2 by to get 9. So if I want to get rid of the y's, I'd have to multiply both equations by a number in order for them to match up. But with the x's, if I multiply this first equation by -3, I'd be able to eliminate the x's. Because remember, what we're looking for is to get rid of it, one of them has to be positive, one has to be negative, and they both have to have the same coefficient, meaning the number that's attached to the variable. So I'm going to multiply this first equation by -3. And doing so gives me -3x minus 6y equals -33. Now make sure that when you multiply everything by -3, that you multiply everything by -3. Don't forget to multiply the 11 way down here by that -3. That's one of the common mistakes that I see people make. Okay, so now I'm going to write underneath it the other equation, which was 3x minus 9y equals 23. So if you notice, when we add these together, well, -3x plus 3x, that's 0. -6y plus -9y is -15y. And -33 plus 23 gives me a -10. When I divide both sides by -15 to get the y by itself, I get y equals 10/15, which reduces to 2/3. Remember to always reduce. Otherwise, you'll lose a half a point when you come to a quiz or a test. So we reduce that because 5 goes into 10 2 times and 5 goes into 15 3 times. Okay, so now we need to figure out what x is. Now I want to put 2/3 into one of these equations. Now, we want to put it into the easiest one, which isn't necessarily the one with the smallest numbers. Look at x plus 2y equals 11. It'll actually be easier for me to put 2/3 in the other equation. Do you see why? Well, if you didn't catch that, the reason why is because if I put 2/3 in here for y, 9 times 2/3 is going to give me a nice number. It's going to give me an integer, not a fraction. So let's put it in that one. So it's going to be 3x minus 9 times the 2/3 equals 23. So it's going to be 3x minus, well, to multiply these together, well, 9 times 2 is 18. So you just multiply the 9 and the 2 together, because 9 is the same as 9 divided by 1. So 9 times 2 is 18, divided by 3 gives me 6. So now I don't have to worry about using fractions until maybe my answer. So I'm going to add 6 to both sides. So I get 3x equals 29. Now divide both sides by 3. And I get x equals 29/3. That can't be reduced. So I have y equals 2/3 and x equals 29/3 is my answer. Okay, why don't you guys work on this next example and pause it and hit play when you're ready to check your answer. Okay. So what you should have noticed is this one you want to get rid of the y's, because if I multiply the first equation by just a 2, I'd get -12y, and I already have a positive 12y below there, so they would cancel each other out. So it's going to be 10x minus 12y equals 6. Then below that, the other equation would be 2x plus 12y equals 12. So I'm going to add these together. 10x plus 2x should be 12x. -12y plus 12y would be 0. 6 plus 12 would be 18. Now when I divide both sides by 12, I get x equals 18/12, which reduces because 3 goes into there, and actually 6 goes into there, would be a large number. 6 goes into 18 3 times, and 6 goes into 12 2 times. Or you could write it as 1.5. So now we know my value for x. So now we're going to put x into either one of the other equations. Now remember, this time we're putting it in for x. That's the other thing you want to make sure you do. Don't put it in for the wrong variable. So I'm going to use the second one because then that way, when I take 2 times 1.5 or 2 times 3 halves, it's going to give me an integer again and not a decimal, where if I put it in the first one, I'd end up with a decimal. So I'm going to do 2 times 1.5 plus 12y equals 12. Well, 2 times 1.5 would be 3. Subtract 3 from both sides gives me 12y equals 9. Divide both sides by 12 gives me 9/12. Well, that reduces, 3 goes into both of those, so that reduces to 3/4, or 0.75. So here you can say x equals 1.5 and y equals 0.75. Or you could have used the decimal or the fraction equivalents. Let's look at how this works with the story problem. Now, if you have my notes, I never got this table put in here, so you want to add that table to your notes. But here it says long distance runner Mary Thon, again, funny about the name there, Mary Thon, wants to get 800 calories and 50 grams of protein from a dinner course of chicken and pasta with sauce. Protein and calorie counts for each item are given below. How many ounces of each type of food does Mary need to eat? Well, so we have our table. We want to create 2 equations from this. Now, we can use C to represent chicken, and P to represent the pizza and the pasta and sauce. So these equations would give me the total amount. The first equation is going to give me the total amount of protein that I would need, where it's 9. I get 9 calories or 9 grams of protein from the chicken. I get 2 grams of protein from the pasta and sauce. And I need a total of 50 grams of protein. So my equation would be 9C plus 2P equals 50. My other equation is going to be 65C plus 45P equals 800. Now notice with this one, there's no way I can multiply just one equation by an integer to be able to cancel out my variables, to cancel out one of the variables here. So what I have to do here is I have to multiply both equations by a number. So I think it's going to be the easiest to get rid of the p's, because here I can multiply this first equation by negative 45, multiply the second equation by a positive 2, and as a result I'm going to get rid of the p's. So when I take negative 45 times negative c, 9c, or times 9c, that's going to give me negative 405c. Negative 45 times 2 is negative 90, be negative 90p. And negative 45 times 50 is going to be equal negative 2,250. Multiply everything by 2 in the second equation, that's going to give me 130c plus 90p equals positive 1,600. When I add these together now, I'm going to add negative 405 plus 130, that's going to be negative 275c. These are going to be gone, so that's 0. And this would be negative 650. So now when I divide both sides by negative 275, I get c equals 2.4. Meaning I need 2.4 ounces of chicken. Now to figure out how many ounces of pizza or pasta and sauce I would need, I'm going to put 2.4 into either one of my original equations. Okay, you always want to go back to your original equation, so one of those two, I'm going to put 2.4 in for C. Looks like it'd probably be easiest for me to do the first one. So I'll put 2.4 in there for C, so it'll be 9 times 2.4 plus 2p equals 50. Well, 9 times 2.4 is going to be 21.6, which gives me, when I subtract both sides by 21.6, that gives me 28.4. Divide by 2 gives me 14.2. Okay, so I'm not going to do these next examples with systems of 3 equations, but in the next video I will show you a couple of unique situations with elimination and how you can tell if it's going to be no solution or infinite solutions. But otherwise, good luck on your assignment.